If mere implementation inheritance is not enough to give you this strange sense of power that you could destroy the universe as we know it using bizarre tools, well, here's another one for you, casting, that can also put you into a lot of trouble, but could be useful. Okay? So let's start by making an observation. Okay, an important thing I need to make sure you know is that the compiler is going to decide whether or not things are okay based on the compile time types of, for now, just variables. We'll talk about expressions in a moment. So recall that every variable in Java has both a compile time type and a runtime type, which are also sometimes called static and dynamic type. Okay? So for example, this instantiation of vengeful slist, it has a compile time type of vengeful slist because it's declared here, and it has a runtime type also of vengeful slist because that's the new that was used for it. Okay, so if that seems unfamiliar, maybe go review that from the previous lecture. Okay, so of course, since it is a vengeful slist containing here the number 9, we can then go through and insert the number 50. Okay? Then we get to this line. Is this line okay? Well, it turns out that Java says yes, right? When we talked about before that S-lists can go inside of list 61b memory boxes, just so. A vengeful S-list, because it is an S-list, can live inside of an S-list variable. Okay, so in other words, these variables can both point to the same vengeful S-list instance. Okay, we have VSL and SL, and look at that. They're both pointing at vengeful S-list. Okay. Now the danger comes along later when, for example, we call VSL.deleteBack. That's totally fine. But then if we try to use SL to print the lost items, we will get a compilation error. Okay? So even though the SL is pointing at this vengeful S-list item, it is not able to print out these deleted items because of the fact that Java decides whether or not you can make a call based on compile time types, not runtime types. Okay? And the simple reason is the compiler, although in this case it would be easy to figure it out, it plays it really safe. It isn't really sure that this SL is actually a vengeful S-list. So it's going to say, sorry, there's no such thing as print lost items in the S-list class because it's based on the compile time type. Okay? That's something that, with practice, becomes totally natural. And again, discussion 4, problem 3 is where you're going to get this down. Okay? So now let's suppose we add in another line where we say, so this one's already a problem, but interestingly, let's suppose we just create another variable, vengeful S-list VSL2, and try and set it equal to SL. It turns out that for the same reason, this is also a compilation error. So in this case, what it's going to do is say on the right-hand side, right, what I have here, the compile time type of SL is what? S-list. Okay? Can you put an S-list in a vengeful S-list container? No, because of the fact that not all S-lists are vengeful S-lists. Okay? So even though it is true, SL, well, you can't see me pointing, but SL, its runtime type is vengeful S-list, but the compiler does not know that. When the code runs, it could in theory be fine, but the compiler doesn't know. So the compiler plays it safe. Okay? So that's raising an issue, letting us know how the compiler treats things. Okay? Now it turns out that not just variables, but also expressions have compile time types. So what we can do, I'll just show you, for example, if we use the new keyword, okay, it has the specified compile time type. So this is an expression that creates vengeful S-lists, and it has compile time type, static type, vengeful S-list. Okay, this whole expression has that type. Okay, so one can say that the right-hand side here has the type, static type, vengeful S-list. Okay. Now in this case, because a vengeful S-list is an S-list, this is okay. However, if we do it the other way, okay, if we do it the other way, it does not work. The compile time type of this right-hand expression, right? So Java goes, it builds an S-list, and it returns the address of an S-list. It marks that secretly. That address has like some stuff glued to it that says this is the address of an S-list. So when you try and copy those bits into the vengeful S-list box, this one right here does not work. So the compile time type on the right-hand side here is S-list, and an S-list cannot fit in this area. Okay. So that's new expressions. What about method calls? Well, method calls themselves have compile time type, and in that case, it's equal to their declared type. So the method public static dog max dog that we wrote in lecture 2, this has compile time type dog. Okay, and the call to max dog, when this thing runs, any call to that is going to have compile time type dog. Okay, here's an example to make it clear what I mean. So here's Frank and Frank Jr. They're both poodles, right? In this case, let's assume poodle is a subtype of dog, which makes some sense. Now we can call dog, larger dog equals max dog, these two. And because a poodle is a dog, we're able to copy the bits that have the addresses of Frank and Frank Jr. into the D1 and D2 variable. Okay, that's totally fine. A poodle is a dog, so you can go this direction perfectly fine. This expression will return the address of either Frank or Frank Jr. In this case, it'll be Frank Jr. However, even though Frank Jr., even though the answer to this result, even though its runtime type, of course, is poodle because we gave it 2 poodles, its compile time type for this expression is dog, okay? And thus, as a consequence, suppose then we try to assign instead of, so this line works fine. We get back a dog, we put it in the larger dog memory box. However, in this case, we try and make this call, okay? The sequence of events. Frank and Frank Jr.'s addresses get copied from these poodle variables to dogs, totally fine. Then we return the larger dog, the address of Frank Jr., but it's tagged, it's marked, it's somehow, the compiler knows that that is just of type dog. This side here, it has compile time type dog, and therefore this expression does not work, okay? And this is very sensible behavior for Java to be doing, as we'll see in just a moment. But the summary of like why the syntax error, it's because the right-hand side has compile time type dog, and the left-hand side has compile time type poodle, and not every dog is a poodle, okay? So, we can, if we want, force the compile time type. We can say, you know what? I know that Frank and Frank Jr. are both poodles, and I want to put it in a poodle variable. I'm forcing this, okay? So what we can do is take any expression in Java, and we can cast it using a special syntax where we put the desired type in parentheses before the expression. So I want to say, you know what, this right here has compile time type dog, but this expression, now adding poodle at the beginning, this whole thing has compile time type poodle, okay? And we can use this if the compiler is bothering us. If we know what we're doing and we say, compiler, look, trust me, it's a poodle, right? So what this does is this now works. Well, you can think of it as this max dog call, it's treating this whole expression as having compile time type poodle, and so totally fine to put a poodle in a poodle box. Now let's look at how we can run into a little bit of trouble if we're using casting. So it's a great tool. It's powerful. It allows us to tell the compiler not to do its job, and sometimes that could be a great thing. You'll find opportunities to do this where it feels right. Okay? Now you can be wrong, right? It may be that instead of Frank Jr. climbing inside of the max dog machine and calculating the max, it may be that actually another larger Malamute dog shows up. Frank Sr. gets in the box. So max dog will run just fine. Frank and Frank Sr. are, the maximum is calculated, and Frank Sr. is returned. However, we cannot cast Frank Sr. as a poodle. And the compiler has no idea. The compiler does not know that that's going to be the outcome of the contest between Frank and Frank Sr. because that's only known at runtime, and therefore, when the code is running, we will get a so-called class cast exception, right? So when used properly, it's fine, but watch yourself. It's usually a bad idea, right? So when you're working on projects, I'll say project 2, for example, do not assume that a given list is actually a linked list, right? It could be an array list, who knows? So casting things from a general category down to a specific type, so from dog to poodle, can be dangerous. And so that means, though, that once you start taking advantage of this, we're losing some of that power that Java gives us, this nice, beautiful static type checking that stops errors. So truly, early on, somewhere in one of the first lectures, I said type checking isn't perfect. This is one of the biggest reasons it's not.